Hello everyone, and welcome to the 11th lecture. In our previous 3 lectures, we have discussed 3 numerical problems related to the design capacity of canals, right? So today we are going to discuss our 4th and last problem related to our topic, design capacity of irrigation canal. So let's start with the statement. The statement is saying that the CCA of watercourse is 1200 hectares. CCA. Let's keep writing the given data. CCA. What is given to us? Cultivable command area, which is equal to CCA. There is 1200 hectares, right? This is given to us. Okay. Second thing given to us is the IOI. Cultivable command area is the first thing given to us. Then IOI of sugarcane and wheat, both are given. IOI of sugarcane 20% and IOI of wheat is 40% respectively. Okay, what is given to us? The next thing given to us is IOI. Let's write down the abbreviation. Intensity of irrigation for sugarcane, which is equal to IOI, given to us is 20%, right? And similarly, intensity of irrigation of wheat is given to us, which is equal to IOI of wheat is equal to 40%. 40%, right? This is given to us. What else? After that, the duties. Duties are given to us. Duty of the crop at the head of water course. Duties of the crop at the head of water course. What? Water course head. These duties are given to us at the head of the water course are 730 hectares per cubic and 1800 hectares per cubic respectively. So that means that duty for sugar is equal to duty is represented by D, right? Duty or duty on capacity. You know that duty on capacity we represent it with D or DOC, duty on capacity, which is equal to how much? It is given to us 730 hectares per cubic for sugar and 1800 hectares per cubic for wheat. So duty for sugar is equal to 730 hectare per cubic, hectare per cubic, and then duty for wheat is given to us, which is equal to, which we call it duty on capacity or duty. There is 1800 hectare per cubic, right? This is what given to us. And what we are supposed to find? Given data like this, and we are supposed to find what we are supposed to find. First thing is the discharge. The first thing we need to find is the discharge, right? Discharge required at the head. Which head? Water course head. We need to find the discharge at the water course head. And the second thing we are asked to find is determine the design discharge for outlet, assuming capacity factor 0.8. So two things we are supposed to find. The first thing we need to find is Q discharge, right? But where? We need to find at the head of the water course. Got it? You can call it Q average or Q. Second thing we need to find is Q design. These two are very different things. This is a discharge at the head, and this is the maximum or peak discharge. So we need to find both. The first thing we are supposed to find is what? We need to find discharge at head of what? Of water course. What is water course? For that you need to go back to the previous lectures, but I'll briefly explain it with a figure. So there is, we can call it Q. We need to find Q or Q average. We need to find this one in first part, and in part B we are supposed to find design discharge, which is represented at Q design, which is equal to question mark. We need to find it out. So the first thing is Q average and second is Q design. So let's come to the solution, and first we will try to draw a figure to make things more clear. So here comes the solution for the problem. Let's convert it into black. Okay. So in solution, first we need to draw a diagram and try to understand the statement. According to the statement, we have a 1,200 hectares of area, cultivable command area, right? Let's say we have an area. Let's say this is our area, and this area is cultivable command area is equal to 1200 hectares, right? This is given to us. And then in this area we got actually two type of crops. We got first sugar, right? Sugar, and second crop here is wheat. Two crops, right? So from the source, let's say green gray, okay, let's say we have a canal coming from here, from the source, which is providing water to this field, and let's say say this is our source, right? This is our source. This will make things easier. This is our source from where we are getting water. So according to the data given to us, the duty of sugar is 730 hectares per cubic, okay, and duty of wheat is 1800 hectares per cubic. Got it? This is given to us, and intensities of irrigation are given to us for both sugar and wheat, and we are supposed to find discharge at the head of water course. This is known as head of source, and this is head of water course, because water course always comes at the start of the field, right? So this is the head of the water course. So in first part we are asked to find out the discharge at the head of water course. So we need to find Q here at head of water course. We need to find Q. But the point we need to remember here is that we are supposed to find two Qs, Q1 and Q2, because these Qs are going to be different for sugar and wheat. What's the reason behind that? The reason is that, as we know that sugar is actually we call it PARRENEAL, perennial crop. What does this mean? Perennial crops are those crops which need water 360 days throughout the year. It needs water. So this is the reason. Actually, the sugar is a perennial crop and it needs water throughout the year, 360 days, right? And wheat just needs water for 120 days. It needs water for 120 days. So that means that the Q for sugar is going to be different, and for wheat the sugar Q value is going to be different. So we will find the Q for sugar and then Q for wheat. Then we will combine those, add up both Q1 and Q2. Then we will get the Q at our head course. Got it? This is for part 1. But for part 2, the sum of these two is going to be Q average. We cannot consider it as a Q design. We cannot design our canal on the basis of this value of discharge, because the reason is that we have discussed in our previous video too. We need to design our canal on the basis of the peak value, right? Q design means peak discharge value. So the peak discharge value is going to be at the head of the source, because in between head to the head of the source to the head of the water course, there are going to be some water losses in the form of seepages, or maybe in the form of evaporation and other sources like evapotranspiration. Okay, that is so minor that we actually neglected, but these are the reasons that water can be lost in between head of the source to the head of the water course. So that means that your maximum discharge will be at head of the source. So we need to find Q here. This Q is going to be equal to our Q design, or we call it Q peak. So this is for part B, we need to find Q here, and for part A we need to find Q here. Got it? So let's start with the part A. Part A first, part A solution. So for part A, I think we will try to draw a table that will make the things easier. Let's say we are given with two type of crops, right? And then what else? For each crop we are given with IOI, intensity of irrigation, and duty is given to us. Area to be irrigated. Area to be irrigated. We need to find it. We need to find it out. So our next column is going to be discharge for each crop, right? Discharge, which is Q. So let's find out for each crop one by one. First for sugar, and second for wheat, right? So first fill out the data which is given to us. IOI, intensity of irrigation, for sugar is given to us, which is 20%, right? For wheat it is given to us 40%. What are the duties given to us? Duty for sugar given to us is 730, and the unit of duty is hectare per cubic, right? Hectare per cubic. And this one was given to us, that was sorry, it's 1800, right? So now we need to find out area to be irrigated. We need to find A. As we know that area to be irrigated is equal to cultivable command area multiplied by IOI, right? So for sugar, the cultivable command area is given to us 1200 for both, right? You can see here the CCA is 1200, and IOI for sugar is 20%, which means 20 divided by 100, and for wheat, CCA multiplied by IOI is 40%. So this is going to give us the area to be irrigated for sugar. When you calculate it, you will find out 240 hectares for sugar area to be irrigated, and for wheat area to be irrigated is going to be 480 hectares. So after getting the area to be irrigated, we need to find discharge. For discharge, we have discussed a formula. If you remember, as we know that duty is equal to area to be irrigated divided by Q, right? So here we need to find Q. So Q is going to be equal to area divided by duty, right? Area to be irrigated divided by duty. So in case of sugar, what is our area to be irrigated? Area to be irrigated is 240 divided by duty, for it is 730. You will get the answer as 0.328. Okay. And in case of wheat, area to be irrigated divided by duty. Area to be irrigated is 480 divided by duty is 1800. 1800 is the duty. So when you divide it, you will get 0.266. So as we said that we need to find out the discharge Q1 for sugar and Q2 for wheat. These are the discharges at our water course. Right, as we have mentioned here at the water course, you can see this. Here we need Q1 and Q2 for sugar and wheat. So the values of Q1 and Q2 are going to be this. But what we are asked to find out the total discharge at water course, right? So the discharge at water course for both sugar plus wheat is going to be equal to 0.328 plus 0.266, which is equal to 0.595. This is our Q at water course. You can call it Q average too. This is our part A. And now for part B, part B, what we are asked to find in part B, we are asked to find the Q design, right? In part D, we are supposed to find Q design. So for Q design, we have discussed a formula in our previous lecture, lecture number 7, when we were discussing the important terms related to the design discharge. We studied the formula, which was capacity factor. What is capacity factor? CF. Capacity factor is equal to average discharge divided by design discharge. Okay, so you can see that from here we can find the Q design. We already have the value of this one, and we are given with the CF, capacity factor. There it is. We need to assume the capacity factor as 0.8. It is given to us. So it's now simple. You can just put the values. Capacity factor 0.8 is equal to Q average is our 0.595 divided by Q design. So from here we can find easily the value of Q design, which is equal to 0.595 divided by 0.8, which is going to be 0.743 cubic. Got it? So what are our answers? For part B, the value of Q design is this. For part A, the value of Q at water course head is this. So in the image you can see that our design value is going to be 0.743, right? And what is our discharge at water course head? That was 0.595. That means that there are some losses in between our head of source and head of course. That's the reason there is difference in discharge at the head. The maximum discharge is 0.743 and the minimum is 0.595. So we got the answers for both parts, right? We already found Q or Q average, and then we find the value for Q design. So that's it. We are done with the fourth numerical. So in our next lecture, we are going to start the designing phase of irrigation canals. So our first theory will be related to the Kennedy's theory. So in our next lecture, lecture number 12, we will start our designing phase of canals. So this was the last problem for the topic design capacity of irrigation canals. That's it. Let's wind up here and see you guys in next video with our new lecture. Till then, goodbye and take good care.